Hi everyone, today we will be starting Unit 2B by talking about multi-step inequalities. So let's review some vocabulary. An inequality is a math sentence that compares two expressions. So an example could be x plus 3 is greater than 14. A solution is a value for a variable that makes a statement true. So we could replace that x with 20, and then we could say 20 plus 3 is greater than 14, and then we see that that is true. And in inequalities, a solution could be any number that could go in there to make that statement true. Inverse operations, well, this is just a repeat from what we did in Unit 2A. It's the opposite operations that cancel each other out. So adding 2 and subtracting 2, multiplying 3 and dividing 3. Step builder notation, again, we talked about that last unit, and we're going to be talking about that again this time around. It's a formal way to present your solution. So what we've done in the past was the curly brackets, the variables, such that the variable equals whatever the solution is. All right, solving inequalities. We solve inequalities just like solving equations. We use the inverse operations, and we can follow SADMEG. Remember, that's just the opposite of our GEMDAS. We take care of subtraction and addition, then we undo division and multiplication, undo any exponents, and then undo the grouping. So special rule, if you divide or multiply both sides by a negative number, you must flip the sign. This is usually the last step. This will usually be our last step that we do. All right, so let's solve, check, graph, and write in step builder notation. All right, so our first step is just like any other time, we like to draw that line. So now, here's my variable term that I need to isolate. So just like I'm solving a regular equation, I'm going to use my inverse operation to undo that subtraction. So I'm going to add 12 to both sides. And once I've done that, it gives me negative 3x is greater than 21. These here cancel out. All right, then I can undo my multiplication by dividing both sides by negative 3. So now this is where we have to be careful, because we are now dividing by a negative number. And when we divide by that negative number, this sign here has to flip. So now it goes from being greater than or equal to less than or equal to. All right, now that we've isolated our variable, we're done. All right, so we need to check. In order to check, we pick a value that will make the solution true. All right, so we want to pick any value that would make this solution true. So we're looking for numbers that are less than or equal to negative 7 to plug back in. So we're going to take our we're going to take one, and we're just going to say, you know what, let's use negative 10. We can pick any number we want as long as it is less than or equal to negative 7. So we're going to pick negative 10 because that's less than negative 7. And then we can take that negative 10 and substitute it back into the original inequality. And now we can take this part here and we can start working it out. So negative 3 times negative 10 gives us 30 minus 12 should be greater than or equal to 9. We do that math. 30 minus 12 is 18. 18 is greater than or equal to 9. We just need to check to make sure that any number that's less than or equal to negative 7 would make this true. And so we've done that. So now let's graph. So my solution was negative 7. So I'm going to start at the negative 7. We have to put some kind of a circle, either an open circle or a closed circle. So if we remember from past experience, if it's got that line underneath, it's a closed circle. Right. Then we're going to draw a line in the direction of all values that are less than negative 7. So in our case, it would be to the left. Okay. So let's go to the next page, and I want you to try this problem on your own. Go ahead and pause the video now. Okay, let's take a look at this next part here. So solving multi-step inequalities, we must distribute, combine, and then solve. Okay, distribute, combine, and then solve. So this follows along with the things that I've been talking about, how I like to split up into a two-part process. We simplify, so that's this part here, and we are simplifying, and then we solve. So remember, I always group this part down here into simplify and then solve. All right, so solve the inequality and write your equation in set builder notation. So here we have this equation here. The first thing we need to do is take this 5 and distribute it to everything inside. All right, so we're going to take that 5 and we're going to distribute it to the 3x, and then we're going to distribute it to the 5. All right, so 5 times negative 3x is negative 15. 5 times negative 5 is negative 25. So we end up with this inequality right here. All right, so now the next thing we need to do is combine. So we distributed, now we're going to combine. And remember, when we combine, it's on the same side. So over here, we can combine the negative 25 and the positive 15. So now we're left with negative 15x minus 10 is greater than or equal to negative 85. And I can always draw my line if I need to. All right, so now we've done our simplifying. So now we can go to solve. So now to solve, here's my term with the variable. I want to isolate that, so I have to move this minus 10. I'm going to undo that subtraction by adding 10 to both sides. Once I do that, that will cancel this out. And now we are left with negative 15x is greater than or equal to negative 75. Last step, now we're going to divide both sides by negative 15. Okay. And once we do that, this here will once again cancel out. And we are left with x is less than 5. So once again, we divided by a negative number, so our inequality symbol has to flip. So instead of being greater than or equal to, now it is less than or equal to. All right, so let's put our answer in set builder notation. Right? It's really just this solution, and then we build everything else around it. And then we can graph. All right, so remember, if we wanted to check that, we would pick a number that's less than 5. So when we go to do our number line, in this case, I always like to take whatever my solution is, if the number line's not already built, and put my number right in the middle. And then I just add in the other numbers around it. Okay? So I always take my actual solution, put that right in the middle, and then put in the rest of the numbers around it. All right, so now we can go ahead and graph. So I need values that are less than or equal to 5. Well, so it's less than or equal to, so it's going to be a closed circle again. Whoops. Where's my circle? There's my circle. And then I needed all the values that were less than 5. All right, so I want you to come down here, and I want you to try this problem on your own. Go ahead and pause the video now. Okay, let's go to the next page, and let's solve this one here. So just another multi-step inequality, but again, we have to make sure we're always paying attention to what's happening in that inequality. So I have parentheses, which means I have to distribute. What is it that I'm distributing this time? Well, I need to distribute that negative 2. So remember, there's that minus sign, which really means plus a negative. So we're going to take this negative 2, distribute it to the x, and then we're going to take the negative 2 and distribute it to the 3. All right, so we're going to bring that 4x down, and when I distribute the negative 2, it becomes negative 2x minus 6. All right, now we've distributed. We need to finish our simplifying process, so the 4x minus 2x, we'll combine those like terms, gives us 2x. Minus 6 is less than 5x plus 6. Now I need to work on getting my variables together. So you pick whichever one you want to use. So in this case, I'm going to subtract the 2x from both sides because I just want to keep my variables positive. So to do that, I move the smaller of the two variable terms. So I subtract that, those cancel out, and now we are left with -6 is less than 3x plus 6. All right, now our next step is to isolate the variable term. So we're going to subtract 6 from both sides. Cancels out. Now we're left with -12 is less than 3x. And now we can divide both sides by 3. Cancels out. And we are left with -4 is less than x. Now when we go to put that into set builder notation, we have to flip that around. It cannot be written in this order. It has to be flipped around. So see how that is open to the x? When we flip it around, it has to stay open to the x. So I'm going to put that over here. So my x is greater than -4. It's the same thing here. -4 is less than x, or x is greater than -4. It has to be with the variable first when we put it in set builder notation. All right, so now let's write or graph our inequality. So I need all values that are greater than -4. All right, so I need to make a number line. So I'm going to put that -4 somewhere in the middle and then just build around it. So there's my -4 in the middle, and then I build around it. All right, so I need all my values that are greater than -4. So I'm going to start. Since it is, it's just greater than, it's not or equal to, then we have a closed circle. I mean an open circle. And then we need all the values that are greater, so that means we have to go to the right. So no line underneath means open circle, and then we're heading to the right. Okay, I want you to try this next one on your own, and this is our last problem, so you can stop the video now. I'll see you in class next time.